Good morning to everyone, and thanks for attending this webinar on Tdyn Glass. My name is Daniel Sa, and I will be hosting this short webinar, which intends to be a brief introduction to the latest finite element technology applied to glass industry. Tdyn Glass software has been developed by Compass in collaboration with the company Vidrio Engineering. So, during this webinar, Tdyn Glass features and capabilities, as well as glass container manufacturing consultancy services provided by Compass, will be introduced. Also, 3 Tdyn Glass application examples will be shown. So you can see we will be showing an impact test, vertical load, test analysis of a 3D glass container, and also we'll be showing a study of the thermal response of a complex 3D blank mold used in the glassmaking industry. So afterwards, any questions and commentaries, please send them to danielsa@compassis.com. So let's begin with the description of this new tool, this new simulation tool, Tdyn Glass. Tdyn Glass has been created with the intention of providing a unique simulation tool for the analysis of glass container manufacturing processes. This solution can actually represent a powerful analysis and prediction tool. One of our main goals in this development was to minimize the time required to create the simulation models and actually perform the simulations. Therefore, a fully integrated and advanced 3D graphic user interface has been created. Tdyn Glass incorporates the latest technology for simulating blow-and-blow, for example, or press-and-blow processes, and also blank and final mold cooling optimization can be performed, together with thermomechanical analysis of forming tools as baffle, neck ring, or bottom plate. Regarding container assessment, a wide range of different standard load tests can be simulated, as we will see later. Together with the development of Tdyn Glass simulation tool, and based on the experience acquired working for glass container manufacturers, an assessment service has been created in order to provide engineer and virtual prototyping services for glass industry. Thanks to this professional approach, the state-of-art computational technology enable container manufacturers to market optimized new designs with considerable cost and time reduction. So these consultancy services, we think, can help in the evaluation of customer new concepts, as for example the development of blank cavity layouts, or for example Parison design assessment by means of finite element analysis. So finite element analysis will be also used to provide assessment for structural verification of containers in order to match quality criteria and for mold equipment conception, performing thermal simulations. To sum up, Compass consultancy services, provided together with the collaboration of Vidrio Engineering, we think can help to optimize the different glass container manufacturing processes, such as blank and final mold cooling, thermal response of forming tools, process timings, container final thickness distribution, or for example, hot end coating efficiency. So, to finish this brief introduction, before the examples, just a comment on the different types of structural assessment on containers which are provided. For example, static and dynamic verification for vertical, lateral, or internal pressure loads, couple thermomechanical shock test, or dynamic nonlinear pendulum and bottle-to-bottle impact tests. All these tests are performed by means of finite element analysis simulation. So let's begin with the first example. This example will show the result of an impact test, which is a basic mechanical test performed on glass containers and which can be simulated with Tdyn Glass. the bottle, in this case, and the sphere contained in the pendulum impact tester have been modelized. Only half the geometry is used in the simulation, so to take advantage of the problem symmetry. This, well, as you can imagine, reduces considerably the calculation time. In this case, the corresponding impact velocity is 9.052 meters per second. So there you can see the recorded result from the simulation and post-processing, and you can see the different stresses results. In one of the simulations, you can see the result corresponding to the Rankine stress range and the first stress result. Okay, so the next example, which will be showed later, will be the automatic creation and calculation of models corresponding to container assessment tests, which can be performed with Tdyn Glass. In this case, we will see the vertical load test on a glass container. And as I say, we will see it later in the interface. And the last example we will going to see will show the generation of a simulation model corresponding to the cyclic thermal response of a blank mold. Also, we will be seeing the results. So, okay, let's begin. With the first example corresponding to the vertical load. In this case, we will configure a container assessment study, and it will be a mechanical test. In this case, we have a wizard, an interface which will guide us through the creation of the model. So a full computer-aided engineering model will be generated, including the container geometry, the boundary conditions, the material assignment, and also the applied loads. In this case, also structure mesh will be automatically generated. Only half of the geometry will be generated to take advantage of the symmetries. So we will choose the unit, geometry unit will be millimeters, and we will see the wizard. In this case, we will be using a bottle profile. Coming from a previously geometry model. So the profile will have to come with previously defined layers, geometry layers, following this scheme. And we will directly import it, as I say, from a previously created geometry CAD file. So in the next step, as we say, we are going to perform a vertical load analysis, so the user can directly insert the value of this punctual force. And we are going to allow the program to generate the mesh automatically. In this case, structured hexahedra mesh will be generated. So we click the finish button, and we directly obtain the model, the full geometry, and the full model mesh. So as you can see, the hexahedra element structured mesh has been generated. Hasn't taken much time, and what is more important is the whole model setup has been already created for the user. So it's as quick as half a minute, and we have a static linear analysis already set up. As you can see, the units are set to millimeters, which is the unit which we checked in the wizard window. And the constraints have also been applied. You can see, for example, the bearing surface constraint at the bottom of the bottle. And of course, the symmetry constraints the edge of the model. So they are already being created and applied, assigned to the geometry. Okay. Regarding materials, you can see they have also been applied. The material, in this case, common glass, has been assigned to the bottle geometry, to the volume in this case. And of course, a vertical load has been created with a value chosen by the user and assigned to the corresponding surfaces. See, the load has been assigned to the top surface of the container. So the only thing left is to save the model. You can choose another name and just save it. And now we just have to hit the calculate button. We can see the information of the process during the on process. You can see the amount of memory the process is taking, the degrees of freedom, and well, some other information of the time taken by the solver to get to a solution. Okay, so the analysis has finished, and we can directly go to the post-process to see the results. Okay, so as you can see, the post-process menu, there's some animation controls which we don't need now because this is a static analysis, so we can close this panel. We will see this later with the cyclic thermal blank mold analysis, but in this case we are especially interested in this case, for example, in the displacements, which is the natural result of the analysis. We can see the deformation with a defined factor, for example, 100 times. You can see also the original geometry and the deformed geometry. So another very interesting results in this case are the Rankine criterion, stress criterion. So we're going to see this result. And of course we can change the units, for example megapascals, and we can set a different stress limits, so we can see the trouble zones. As you can see, top of the bottle and in the bottom. So you can see the transparent there. We can change this just for visualization. As you can see, there are multiple options for getting visual results and pretty results, so the user can customize this. Can also get additional information on any node or any point. Just in some special point we want to check. See, information box or some detailed information about a certain point and the elements surrounding, the corresponding mesh, the element type, and the results, area integrals, in the volume, in the surface. So let's go right on to the next example, which is the blank mold thermal response. Let me show it to you. And as you can see here, it's a blank mold. We can see the flat render, so it's better seen. So this model has already been created and imported in the interface with certain previously created layers corresponding to the different zones of the mold. As you can see here, in this case we will just only using the blank layers, and we have to choose the analysis we want to perform, so to let the program automatically assign the correct conditions. So as you can see, sum up, once the geometry of the mold is inserted in Tdyn Glass with these predefined layers I have shown, the program will automatically set and assign the heat flux on the corresponding surfaces. So that means the correct boundary condition. Also, the mold material will be automatically assigned. So in this case, we are going to perform, as it is already selected there, a heat transfer analysis. The units of the geometry are millimeters. As you can see here is a blank mold cooling design. See, this could also be done with final mold cooling, baffle, neck ring, guide ring, or bottom plate. In this case, it's a narrow neck press blow. Okay, so we choose heat transfer analysis. And in a minute, less than a minute, the model will be set up with the correct boundary conditions, assigned materials. Okay, sorry, I think I lost the connection. Hope you are still there. Okay, I was going to show the conditions. Yeah, okay, the model already created with the conditions assigned. This is going to be a heat transfer analysis. It's a dynamic analysis with the time evolution. And you can see all the conditions and the mesh already generated. And if I draw the assigned conditions, you can see each one corresponds to the defined zone. You can see there in red the contact zone with the glass, and in green the blank mold outer face with the cooling surfaces. So also the material is assigned. It's a cast iron mold. You see, applied to the model, to the volume. And in this case, the analysis data you can see all the timings and specific parameters of this analysis. In this case is 10 cycles with 74 steps per cycle. And we have set a cavity rate of 8.12, corresponds to the rate of cycles or bottles that can be manufactured per minute. So in this case, the period per cycle is 7.4 seconds, corresponding to this cavity rate. Depending on these parameters, here the cavity rate and the steps per cycle, which can be modified by the user, then the number of steps and the time increment corresponding to perform the analysis is automatically calculated. So, as you can imagine, this analysis takes a bit more time because it's 740 steps. So we're going to go directly to the post-process so I can show you the results. Okay, so in this case, we are going to keep the animation controls because we can perform animation. This is a dynamic analysis. We are going to change the units to degrees centigrades, and we are going to show the contour field of temperatures in the mold. You can see the first moment. And for a better visualization, we're going to set the limits of the results, for example, to 350 degrees and 420. And as we did before, we're going to set the colors. Okay, this has already been correctly set. And I hope you can see the animation correctly, not interfered by the internet refreshings. I'm going to start the animation. You can see the first moments and the temperature variation in the contact zone with the glass as the cyclic process is taking place. I will play it again and hope all of you can see it, because I'm not sure the refreshing of the internet allows to see the animation. So, of course, we could see this temperature variation on a certain point, as we did before with the stresses on the glass container. For example, in the contact zone with the glass, we can select a point and get a time graph of the temperature evolution. So it's hidden here, but it's still here. So we can set the limits or the axis limits of this graph. For example, from 380 to 411, as it is there, and we can see the cyclic evolution, of the glass contact zone for that certain point during the whole 70 seconds time evolution of the CFD analysis. Okay, so that would be all. I'm glad you were here listening to this webinar and hope to hear from you again. As I said before, you have my mail, so you can send me all your questions and commentaries to this mail. So thank you very much, and bye-bye.